lost my session. I'm sorry. So I'm on
No
the
issues.
stage here. Great. So I think folks can see me and hear me okay?
Yeah.
Can we make sure that the session is recorded, and then I'll go?
Yes, the session is already being recorded.
Fantastic. Good afternoon, everybody. Thank you so much for joining us. My name is Jason Davis, and I run product management at Backtrace IO. Backtrace is a crash and error reporting solution, and we are here today to talk to you about what we've learned from game programmers, producers, technical directors across the industry over the last few years to understand what tools and processes they love to use as they're building their game from production all the way to post-launch. A little background on myself before we get started. As I mentioned, Jason Davis, I run product management at Backtrace. Backtrace is a 6-year-old, relatively new startup, if you will. We focus on crash and error reporting. We are a verified solution partner with Unity Technologies. We are also a certified middleware partner with game console vendors, Sony, Microsoft, and Nintendo. We are fully supported with Epic's Unreal Engine as well. And generally, we help game programmers and studios provide stable experiences for their players. The talk today is based on dozens of interviews that I've given and taken over the last 2+ years to folks across the game industry. As I mentioned before, tech directors, programmers, QA folks for small, medium, and large game studios, all with varying skill levels. Before we get into the talk, I want to give you a little more background on Backtrace, which should also help give you a sense of our kind of perspective and what we're looking at as we're looking at game programming and game development. So Backtrace, as I mentioned, we provide crash and error reporting for every major gaming platform, including PC, game consoles, as well as mobile and web-based games. We support every engine and every platform, as I mentioned, Unity partners. We work with Unreal, Stadia, Lumberyard, any custom engine as well. And we capture errors, hangs, fatal crashes, etc., from games that are running either in production or in the release mode or while it's being developed in production. We also integrate tightly with build pipelines to catch build failures, testing issues, performance issues, any sort of test or analysis that you might be running during your build pipeline. You can feed those errors into Backtrace and allow you to analyze, triage, and understand what problems might be impacting your games. And finally, what makes us different from other solutions? You might have seen crash reporting solutions for mobile games. What makes us very different is not only that we're cross-platform, but what we've developed a purpose-built database technology that's designed for high cardinality crash and error data. It means that we can take hundreds of attributes and hundreds of key value pairs, index them, and query them in a very efficient manner. And this allows you to make use of the data that we've collected for your game errors and crashes in a really interesting way. So I won't spend too much more time talking about Backtrace. This just should give you kind of our perspective, where we're coming from, and what we've been talking to customers about. All right. With that said, for the next 20-25 minutes or so, we're going to spend our time talking about the items here on the screen. First, a brief overview and kind of level set on the game development lifecycle. Let's make sure that we're all talking the same language, we have the same types of phases that we're discussing. Then we'll briefly talk about the different dimensions that impact what causes teams to implement different phases of the game development lifecycle and choose different tools as they're building their games. And then we'll spend the bulk of the presentation talking about the tools and processes that we heard game developers love from the folks that we've been talking to. We break it down into 5 phases of the game development lifecycle, but we'll look at it here in 2 top-level phases. One, the creation phase, creating and building your next game. What tools do you use there? And then the stabilization and monetization phase. When you're getting ready to publish, what tools and procedures do people use? Once they publish, what do they use to make sure they're monetizing, etc.? And then we'll wrap up. Okay, so let's start off with the game development lifecycle. From the creation phase all the way to the operate phase. So I've seen game development life cycles that have more phases than this, less phases than this, but for the purposes of the talk here, I've got 5 phases that we'll talk about tools and processes within. First, your pre-production phase, right? This is before you start building your game. You're designing it, you're prototyping it, you're testing your idea, you're seeing if this game is going to be something that's worthwhile to build. So tools that are used here usually deal with prototyping, initial feedback, maybe some understanding of what type of engine and form factor you're going to deliver your game on. The second phase, this is where the bulk of your time is usually spent, the production phase, building your game, programming your game, developing the assets, the videos, the physics, the audio, and then collaborating with your team members to make sure that you're building and producing the highest quality game that you can. Third, and I see this often in the game life cycle, in the game industry, is the testing phase often is isolated, and you do have a period where your production is kind of done, you're done with features, and I've got just pure testing, be it beta testing with just the internal team, with friends and family, black box testing. Depending on the type of game, you might have more performance testing involved. So there's a period where there are a set of tools and procedures used to test the game, make sure feedback is fed in the right way, and that the top issues are fixed. There's usually a short cycle for pre-launch. Some organizations have like a few weeks after testing to focus on corner cases, on bugs, on hardening, basically no new features, but making sure that the game is ready for launch day. And then finally, post-launch. After the game is live, you're not done. You still need to, especially in this day and age, understand usage patterns of your users, understanding your analytics. Not every game is pay up front and just play forever. Often you have retention of players that you're concerned with. What is the monetary value of the player? How much revenue is each active player bringing in? These are the sorts of things that you need to concern yourself with post-launch. Right? So this talk is going to be discussing the different tools and categories of tools that people use throughout these different phases. Now, not every organization is the same. As I mentioned before, you've got small game studios. They could be indie, 1 or 2. You have medium-sized game studios, 10 to 20 to 50 engineers or programmers perhaps, and then large studios as well. You also have studios or games that are delivered on different form factors. These different dimensions impact the choice of tooling that companies use. So to start off with, just to talk about form factor for a moment, right? Games that are delivered on PC and console are typically higher performance, better graphics, more involved gameplay than those delivered on the web and mobile. So for that reason, performance analysis, profiling, and even just visual feedback on artistry is typically more favored in the PC and console world and less used in the web and mobile world, right? So when we talk about performance tools, we'll see things focused much more on the PC console games than we will on web and mobile. On the flip side there, games that have been built for mobile are very familiar with tools like crash reporting because you've had tools like Firebase and Crashlytics for many years. By the same token, those tools really haven't existed for PC before. So again, the form factor has dictated kind of what tools and procedures people use. Other dimensions that impact the tools that people need, multiplayer. Is this a live game? Is this a game that's going to require servers where you're going to have multiple people connecting and having live gameplay? How large is your team? How much collaboration is needed? How much work between your QA and your engineers needs to be done? And how complex is your game? So these types of dimensions, we'll refer back to them as we begin to discuss some more about the tools that people use throughout these phases. So now to get into the kind of the meat of our talk here, let's go through those phases of game development, and we will discuss kind of the class of tools that are used and some of the decisions that have gone into the different tools that are used within those classes. So first, during pre-production and production phase, you're typically going to choose your editor and engine, right? two of the most popular editor or engines on the market, the Unity engine and the Unreal engine. We have many other engines, Godot, Lumberyard, custom engines. Large AAA studios have their own proprietary engines. There's a number of other third-party open source engines out there. The engines are great because they provide for you, as you guys probably very well know, physics, audio, video, like all of the components that you need to make your game. We see people, a majority of folks using either Unity, Unreal, or their custom engine, as well as Lumberyard. We see Lumberyard because we work closely with the team at Amazon and Amazon Game Studios. Some of the dimensions that will cause a studio to choose one of these engines versus the other really does, some of those decisioning factors have become how do we say, more standard over the years. What I mean to say here is that historically, Unreal has been used for quote-unquote AAA games, high-performance games with photorealism in their graphics and so on. And historically, Unity has been used more often in the mobile space and in the 3D VR space. Now, that's not to say that Unity is not used for AAA. We have a number of studios that we've worked with that use Unity on AAA, on game consoles, and so on. And the opposite as well, Unreal on the mobile side. This is just to kind of give you a sense that historically people have looked at form factor and the complexity of their games as one of the driving factors for the editor that they're going to make use of. The engine they're going to make use of. In addition to the engine, which is running the game, they need to choose editors. Usually, the engine is going to have a built-in editor, but oftentimes game programmers are going to need to use some third-party editors like Visual Studio or IntelliJ. The editors here are chosen based on the engine and the language typically that's being used. Another common tool that's used and decided on during pre-production and production is your requirements management tool. Small studios might use spreadsheets for this, or even old school just Word documents. Most organizations we see do use issue tracking tools. Things like Jira or Asana are used pretty frequently in the game space. Handsoft is a tool from a company called Perforce, which is a little more focused on gaming specifically with regards to requirements management. So I've found Handsoft being used by quite a few game studios, specifically because that team worked on designing their requirements management, their issue tracking around the way that game programmers and game testers make use of requirements management tools. We do see Trello and Confluence used quite a bit as well. Confluence is a wiki site for kind of managing game requirements and so on. The other thing I'll mention about requirements in the gaming space, and again, for you guys and the teams, folks here, this is probably well understood. But what's interesting about gaming requirements is they're not all functional. Right? There's emotional requirements. There's gameplay requirements. There's interesting things that are more of individuals' perspectives. There's visual kind of level of fidelity that's used. So requirements aren't necessarily just functional requirements. And these types of tools are really useful for capturing kind of those non-quantifiable requirements as well. In addition to having requirements management, folks need to collaborate with their team. Typically, Slack, Microsoft Teams, in the gaming space, Discord is used quite a bit. And what's nice here is that these communication tools not only are for your internal team, but they give you a great way to talk to testers once you move beyond kind of the initial production phase. And then finally, version control software. Typically, we've seen that it's the studio or the team's preference for the version control system they've used in the past. Git is one of the most popular ones. Perforce and Helix is very popular as well. One of the main differences that we've seen there, and the reasons folks have chosen Perforce versus a Git, for example, are due to the decentralized nature of Git versus the centralized nature and the ability to handle large objects, large assets for something like Perforce. We also see that with Plastic SCM and Subversion, as well as another version control tool that's typically used. So this is kind of the first set of tools as people are going through their game development lifecycle, thinking about what tools they need to use as they're building their game. These are the classes of tools that they're initially looking at, and here are some of the common initial tools that are used, and as I mentioned, some of the reasons that we've seen them used. As we continue to move through production, a whole other class of tools starts to get chosen and used, right? So now I have my engine, my requirements management, I'm collaborating with my team. I need to have build tools. So typically there are a bunch of open source tools as well as proprietary tools, but Jenkins and Circle CI are common. Again, this is typically chosen based on what the development team is comfortable with. They will typically have used one of these before. If you are an indie shop just getting started, using something like a Unity Cloud build or GitHub now has GitHub Actions, or Azure on the Microsoft platform has a simple way to kind of write your build tools as code, if you will, or write your build scripts as code. When you're writing your scripts and using these build tools to compile your games and pull all your assets in and package them properly, you're going to have different build pipelines. And I call these pipelines out here because we heard from different studios that they have different procedures for the way that the pipelines are run. So the idea here is to give you insight into not only the tools, but what type of procedures they follow. So in this case here, a few different things we want to mention. One, when people start setting up regular build pipelines for complex games and AAA games and those that are going to run on consoles, we'll still see people generating multiple build types. So I have 3 build types listed here: debug, profile, and retail. This is an example of a AAA studio that we've spoken with who says every time they do a build, they've got these 3 build types generated, and they use the build types for different purposes. Their QA team, who's testing performance, is typically going to run on the profile or the retail build because they want to feel performance and they want to feel the lag the same way that their players will. When they're trying to actually debug a problem or they run into a serious issue and they need more information, a debug build is made use of. But typically what was interesting here is that they've got the different build types used, but this studio in particular was very focused on making sure that their testers played the game very similarly to the way that their players would, so that they would really feel the same type of pain with performance and lag and so on. Build pipelines can either be executed in a CI fashion, right, continuous integration, whenever there's a check-in, make sure a build occurs, or on a scheduled basis. I see scheduled much more often in gaming because of the amount of time that builds take. Outside of the gaming world, CI is pretty popular. In gaming, I'm often seeing 3 or 4 scheduled builds a day at certain points of time to make sure that whatever code is checked in at that point, the build occurs. And the reason that it's not CI is just typically that there's long build processes, right? Within these build pipelines, various tools can be used to validate validate the code, validate if there are any errors that occur early in the game building pipeline, the game development process. So specifically here, we heard studios telling us they use tools like map checkers for some engines. For some consoles like PlayStation, address sanitizers and static code analysis tools are required in their tool chain to ensure that you don't have any static code analysis defects. Backtrace the build pipelines can be used to customize and set up your schedules so that these tools are run and errors are generated if there are problems in the pipeline. Right? And we see a lot of people making use of these types of tools pretty frequently. We also see people developing a lot of custom tooling. When they're in production, they need to file tickets, file issues when they're running into them, and there's often a lot of standard information that they can get from the game. What scene was I in? How long was the game running for? What version of the game? What graphic card is being used? Which device driver? Which modules are loaded? All of that information can be available to someone, and instead of having to manually issue them when they're filing their tickets, folks have built custom tooling to feed that in automatically. And finally, during production phase, as you're building your game, if you are a multiplayer game, you're going to be connected and have online services. You need to concern yourself with choosing multiplayer services up front. There are different types of services here. I've listed a few of them, but the idea is that if you need lobby services, online worlds that multiple people connect to and have group gameplay on, or if you just need the ability to scale up back-end servers, these different platforms all provide various tooling in that area. Outside of that, when you have voice and chat, there are tools like Vivox and other audio tools that allow you to do in-app chat and conversation, right? So these are kind of the full set of tools that we saw people choosing as they're in their pre-production and production phases. So moving forward from here, studios will move out of the production phase and move into a full-formed or an isolated testing phase. Testing and pre-launch can be done during build. I've seen about half of the studios really focusing on testing throughout the build process so that their testing, the defined testing phase here is a lot shorter. So I've seen it done in different ways. But usually during testing and pre-launch is where these types of tools here are thought about and considered. So 2 classes here to talk about in testing, crash and error reporting, and performance and profiling and frame analysis tools. It doesn't really matter the form factor. In the past, as I mentioned, crash and error reporting has typically been seen in the mobile space. You've had tools like Crashlytics, which is now Firebase, and Microsoft App Center. And then you also saw vendors like Unity and Unreal providing cloud diagnostics and crash reporting services. Beyond that, I don't have it listed here, but the game console vendors themselves, Sony, Nintendo, and Microsoft, they all provide crash and error reporting solutions. And then Backtrace, my company here, we provide a comprehensive cross-platform crash and error reporting solution that is the only one that's on this list that really focuses on mobile, console, PC, and web. Again, folks start looking at crash and error reporting when they enter their testing phase because that's when they expect to get a lot of errors from their players. Forward-looking organizations and high-performance game studios, I see them incorporating these tools earlier in production, but that's because they're also doing testing throughout their production cycle. The other type of tool that we see during this phase is performance and profiling tools. Often teams are not thinking about performance and profiling until they get very far through production. And again, the form factor is important here. So for console and desktop games, performance and profilers are very frequently used. The engines themselves provide profilers, and then there's custom tooling for things like gathering CPU and GPU statistics and memory statistics. Also, great sets of frame analysis tool. RenderDoc is one in particular that's an open source MIT license that allows teams to look at what's going on within a given frame. There's also a technique called dynamic resolution scaling, which we see used for pre-launch and into launch. DRS, dynamic resolution scaling, is the idea that you can lower the resolution of the screen to keep a high frame rate and adjust that so that if the frame rate is going to drop below a certain level, try and keep the frame rate high by just dropping the resolution. It's a really cool technology that's used for photorealism games that have high performance in that way. The third tool I have listed here is used for, again, depending on the type of game, multiplayer games. Network quality analysis tools are very interesting because as folks are doing multiplayer games and they're trying to diagnose their performance issues, they will sometimes see that it's not a server problem and it's not a client problem, but it's actually network traffic, or maybe it's a streamer or collisions that are occurring. So we need these tools as well during this phase to really analyze what's going on as I get more and more traffic and I'm testing things with more of my my expected load. So also during testing, and again, depending on the sophistication of the organization, sometimes these are decided on earlier, but you have test case management. There's a lot of discussion with the folks we've spoken to about coverage. How much code coverage, how much game coverage do we have? And they need test case management tools like TestRails or Confluence as a wiki. I just recently saw another tool that plugs into Jira, and I struggle to recall the name. I apologize. But a tool that plugs into Jira to do test case management. The whole idea here is that folks need to make sure that the features and the assets that they're building and putting into their game have coverage, that they have been tested, and that they've been used. And teams use these types of tools to make sure that they can go through, create a test plan, and ensure that the test plan is executed on. Beyond the test case management, they do have formal gameplay testing feedback through things like Discord, central QA teams. Large studios will have central QA teams that they will farm out to multiple studios or multiple games titles to work on those games. And then things like Reddit forums to be able to engage with your players and your early access users as well, right? And then finally, automation. Automation over the last year or two has gotten a lot more play in the gaming space. It's really used during testing to run simulations, to provide code coverage, and to do automation as well. All right, so we've covered tools that are used during production, during testing, during pre-launch. Now your game is launched and live. There's still a set of tools and a class of tools that you need to have a great experience, especially with games that are free to play, where you're going to be earning your revenue based on in-app purchases or advertising and so on. So three classes of features or three classes of tools that we see used during post-launch and live. One, analytics tools. These are tools that are useful for you to understand what are your players doing in the game. Are they? How many game sessions have started? How many battles have started? How many times has a weapon been used, etc. These tools here help people provide that information. Some tools come out of the box. Delta DNA, PlayFab have a bunch of things out of the box. I've seen a lot of studios building their own with App Center and Google Cloud and other technologies as well, because to them, it's just a metric store. They can store these metrics and this information and then query it. So there's a wide range of tools that are used for analytics, both packaged and custom. The second thing you have for live games is live ops services. This is everything to ensure that your game has a running economy if it's running. Are you doing in-app purchases? Are you understanding what players are doing live in the game at this point in time? What type of revenue generation do you have, et cetera? So a bunch of third-party packaged products are often used for these types of services. And then finally, monetization in general. Your games are live, you're gaining revenue by running ads or by providing in-app purchases. There are tools out there that allow you to consolidate and aggregate ads from different ad services, as well as ways to make it easy to perform in-app purchases with something like a Unity IAP, for example, or a platform like PlayFab. So a quick kind of tour through the game development lifecycle and a set of tools and procedures and processes that we've seen studios using. To wrap up, the three kind of main things I want you to walk away with. One, not every studio uses the same set of tools, and for various reasons. But the main thing to keep in mind is that there are these different dimensions that are going to impact the tools and processes that are right for you. Dimensions like the form factor of the game, is it online or offline, is it multiplayer, how complex is it, etc. Second thing I want you to walk away with, there are a set of common classes of tools, as we outlined. Your engines, your editors, your test case management tools, your crash reporting tools, your live ops tools, etc. Within each of those tools, there are vendors that provide good competition for you to make choices. However, the right tool might not be available for your studio. So the third point, custom tooling is always something that we see studios spending time developing to help them close the gaps. We often also see studios who have built their own kind of, let's say, crash reporting framework, but have decided it's no longer worth it for them to maintain it. So they'll move to third-party tools. So these are kind of the three main things that we want to have you walk away with. You can learn more about Backtrace both on the Unity's website, unity.com/product/Backtrace, as well as Backtrace.io. We are a third-party independent company, but as I said, we're a verified solution partner, so we run a lot of our gaming business through Unity. That said, fully cross-platform, supporting the Unreal Engine, other custom engines as well. And with that, I'm going to wrap it up and open the floor for questions. So thank you for your time. Oh, great.
Hi, Jason.
Hi.
Hi. We do have one question.
Yes.
Can you click on your discuss panel?
I'm sorry?
Can you click on the discuss button on the right hand side?
Yes, I see the some audience and some Q&A.
Yeah. So Q&A will have this question for you.
Okay. Excellent. So there's a question to go to slide 1 and 2. I will go ahead and do that. And I can have these slides packaged up for you as well. So slide 1, from production to post-launch with Backtrace. I'm not sure if I missed that. Slide 2 here. Who am I? Did I miss the question? Okay. So another question's come in here. Suggest best development lifecycle model for game development.
Okay.
So I'm what I would say for that is, let me just scroll through my slides here. This life cycle is what I see as a set of common phases. All studios seem to be following this type of life cycle. The difference is going to be in where is the demarcation in these phases. How much testing is done during production, for example. So the most successful games that I have seen involve a lot of testing and feedback early, and they address not only bugs, but more they address their gameplay feedback as early as possible. The other thing I'd say is the pre-launch phase and the idea of keeping things open as long as possible is not something that sits well with me. I've seen a lot of games delayed because they want to just hit on some of those corner cases more and more. And I don't know if that's the best approach. I've seen some studies that say, hey, if the gameplay is really good, players will deal with small bugs and small errors, and they'll be okay with it. So I see a lot of people, in my opinion, spending maybe too much time in pre-launch and not just getting their game out there and understanding that their players will deal with problems if it's a good gameplay. So that's a little bit of feedback on what I've heard and what I could suggest in terms of best life cycle. I look to some of that. And the other thing I'll comment on is GDC and other sessions like that have talks from studios themselves, and you could hear from programmers that take you through, here's how they built their game. This talk was meant to kind of summarize for you all the different things we heard and why people were doing things in different ways.
Thanks, Jason. Thanks, Jennifer, for that detailed answer. I think we have no more questions.
Excellent.
We can probably wait. Yes, there is one more question for you.
Yeah, startup studios. I mean, the gaming, so the last question here, for startup studio, it might not be possible to use paid tools. Do you think it's fine to use free versions? Absolutely. There's a lot of open source tools. There's a lot of free tools. There's, especially for indie studios, indie developers, I think you want to pay for good gameplay, for good graphics, for good assets potentially if you're not developing them on your own. The tooling, I think you want to start to pay for when you start to see value out of it. And I think the majority of tools do have free versions. I know both the Unity team and the Unreal team as platform vendors provide free versions of their tools versus like the PlayFabs and the Exolas, which are definitely required for payment. So I think free versions, open source is totally fine. You want to pay when you're getting value.
Okay, and with that, I think we can wrap this up.
Excellent.
Jason, we can go to Backstage.